Hi, my name is Amanda Kautzer, and this is the Gear Enterprise virtual presentation for the Spring 2020 Expo. The Gear Enterprise has 3 projects, which are a sit ski, a cooling aid, and an avalanche beacon. First project we're going to talk about was with my team, made of Mary, Joseph, and Mark, and this is the sit ski project.
The problem with the current sit ski design is the ability to stop, slow, turn, and turn safely.
So the first concept we came up with for prototyping and design uses the idea of a longboard truck. As you can see in the video, this allows for 2 sets of skis to turn independently, creating an arc.
And during testing, this turning arc did form between the skis, but the back side slid out before initiating the turn. To fix this, we implemented fins on the bottom of the ski, and this did help the back skis from sliding out, but they caused a lot of resistance. So after that, we tried cutting grooves in the bottom of the ski, and these did help prevent the backside from sliding out, but they still provided a little too much resistance.
So moving forward with this design, we would like to try using newer skis with a faster base and also using fewer grooves to hopefully still have the turning ability with faster skis. The second concept we came up with was to have a parallelogram frame. The idea behind this was that the user leans into the turn, both skis will still maintain contact with the ground and be on edge, allowing for more stability while turning. The work so far with this design is that we've created a 3D model and uploaded it into Motion View, where we have been working to see how the frame behaves as the user leans. We have also 3D printed a scaled down model of this design.
Prior to the quarantine, I was able to work with the biomechanics department for one of the classes I'm in and collect some data of how the center of mass moves when a sit skier leans back and forth. And that's pictured in the graph in the middle of the screen. And this data allowed us to put real accurate information into the motion view model Mark was just talking about.
In our third concept idea, we decided to use an Alpine brake as a lever to hopefully improve the turning ability as well as the ability to slow down. After testing, we saw that the skis did slow down quite a bit, however, turning was not improved. Moving forward, our intentions are to get a finished working prototype, as well as to build a full-size parallelogram prototype, continue to adapt the sit ski, and improve the seat.
Hello, we are the Avalanche Beacon team. Jared Telsma and our team leader Justin Mintek are 2 electrical engineers, and I'm Adam Brewer, a mechanical engineer. National Geographic reports that each year around the globe there are over 150 deaths caused by avalanches. Our goal with this team is to create a low-cost, commercially available beacon that will help decrease the cost of both the training and equipment needed. Currently, the beacons available to the consumers are transmitting and receiving beacons, so to help find people and also transmit the location if people are stuck in an avalanche. Our goal is to create a transmit-only beacon that will be used specifically for training. This will help increase the simplicity of the beacon itself and lower the cost from the current $200 to $400 price point for a beacon, hopefully down to under $50. To do this, we must meet the industry standards of a beacon that can transmit at 457 kilohertz, plus or minus 80 hertz, and has a 10% duty cycle and up to a 50-meter range.
The first prototype is a prototype that was begun in previous semesters. With this prototype, there was very little documentation provided, and due to this lack of documentation, we were unable to determine what parts were used or why they were selected. In addition, we could not recreate the results that were found in the documents that we did have. Throughout the testing, however, we were able to determine that the prototype needed a function generator to work as intended. We decided to scrap this plan and explore other options which would be cheaper than adding a function generator.
After scrapping the idea from prototype 1, we did a complete circuit redesign for prototype 2. This began with deciding to use an LM555 timer as the main component instead of an operational amplifier to regulate the duty cycle of the circuit. Once the schematic was finished, a PCB board of the circuit was created in Eagle software. While this was going on, the case for the beacon was also being made. An additional prototype was made and then revised to accommodate for a battery compartment and permanent mounting of the completed PCB.
This slide shows the prototype for the avalanche beacon case. This case has clips on either side that allow it to open and close very easily, and this will house the circuit board and antenna for the beacon. Once we figure out what our power source will be, we would need to add a compartment for the batteries, and we will also be using plastic screws to fasten the circuit board down to make sure it does not wiggle at all when the beacon is being moved around. We have to use plastic screws so it does not interfere with any of the transmitting signal.
Moving forward, we'd like to continue brainstorming concepts to add to make the training beacon more user-friendly. Some ideas we've had have been adding a die stack or auditory effects to the training beacon to make it easier for beginners to find the beacon. Also, we would like to finish creating our testing documentation and complete the final testing of the working beacon next fall. Finally, we would like to set up a test using our training beacon on a simulated training course and allow individuals to attempt to find our beacon.
Hello, this is the Cooling Aid Project. Our sponsor is the Air Force Research Laboratory. Our team leader is Cora Jarman, that's me, and my teammates are Morgan Bialek, Carson Deeds, and Joseph Van Lin. The problem we were tasked with solving this semester was that maintenance personnel wear personal protective equipment that heightens their risk of heat stress. We were tasked with creating a cooling aid within the following constraints: to be wearable with a full range of motion, effective for up to 6 hours of continuous use, have negligible risk of foreign object debris. Foreign object debris can cause loss of life in the worst case scenario, and that the prototype be free from odor.
With these initial constraints, we came up with 3 designs, 2 of them active and 1 passive, focusing on humidity. We ultimately went with the passive system focusing on humidity, and that is shown in the bottom right-hand corner. In the center of that diagram is the Velcro pouch, which includes molecular sieves within it to absorb the moisture in the air. We like this design and further went with it because it has low risk to foreign object debris. It's easy to work on due to its simplicity. It does not inhibit user motion as it is just a waistband around the belt. It can last throughout the entirety of the shift, and due to the molecular sieve packets being interchangeable, it is low risk to odor.
After selecting this passive system, we obtained various fabrics and desiccants and sewing equipment to construct our prototypes. These prototypes were made with waistbands and pockets to store the desiccants. Following the construction of some prototypes, we started testing, and we chose a sauna on campus to replicate the 100+ degree environment. And we suited up in the standard issue clothing of Tyvek suits and rubber gloves and a respirator, in addition to our prototypes, and spent time in the sauna. After testing for a few weeks, our overall trends and data indicated that our prototypes did actually help in reducing the sensation of heat experienced by the subject.
In conclusion, our testing results are preliminary and require further validation, but they support the use of these prototypes and indicate that using proper materials for the pouch and the molecular sieve can result in reduced risk of heat stress for aircraft maintainers. 4 new prototypes were constructed and delivered to the project sponsor, so further field testing and assessment can be completed in the future. This testing might look more into the materials for the pouch and materials for the desiccant, the cost of use, the cost of replacing, and the impacts of potentially reusing the materials in the future. And that has been our project this year.
Thanks for listening. Hope you found the Gear Enterprise interesting. And if you have any questions about these projects or joining or anything related to gear, shoot an email to one of our project leaders listed below. And thanks again for listening.